If you go to the properties, and this is the very sorry. So this is, I want to tell that it's a very simple equation. Nothing is there. If you look at that, and if the two particles or atoms are there, it is the building block when they overlap. And what will happen that your factor will become the zero. So that means you can tell that single particle when they separate it happens. The same concept is applied in the nanomaterials, nanocomposite and everywhere, and explain the properties of the material. So just I will give you the idea. So I'm not going to there, what are there. So just you look at it. This is our picture only. And what it is happened that you have a matrix, red color, black dots you are putting the nanomaterials. Both can be nanoscale, no problem. But what happened that when you will keep on increasing 50-50, so no more. They will be, pillars will be interact each other. So they will be no more, they will be independent. So if you look at it, so for example here you look at that, the size is nano, but they are not nano because the same material has come and joined together. So together it is not coming to the nano, so they will not give you the nano property. So that's what I say that 10%, I'll give you example, you will understand easily. We have all the ornaments. It is 91.2. Never we thought that why it is the 91.2. So it is just a alloy. So you cannot go beyond that because you will lose the properties of the gold. And it will not be the composite and which I look for the high strength and it should not be harmful and this thing and gold property will be there. Forget about that. You are using the cement. Same concept in the cement. If you look at its properties, by the way, I know all this because I had a consultancy on the cement and I know its composition. They are also 4 to 5%. We add it. And still you are using for your house building and all. There also only 4 to 5% we add on the steel because to increase the strength. So all the theory lies there. So when you say the nanocomposite, please don't mislead, and it is the alloy or anything, it should be 10% and size has to be nanometer. So if you look at the property and you look at this, so your property at the nanocomposite it will increase, then in the composite it will be some other story, and in the nanocomposite this will be different story. So by looking to this theory, this is just a basic to my friends, and this nanocomposite, we just pick up the polymer and try to make some nanocomposite which can be a generator, energy generator, and that's what we are working. Then we look at our previous research like that which can be the best nano generator. Then we pick up a very good material, barium, strontium, titanium oxide, and what is our beauty? That the student is sitting here, we thought that, and we have to put a conducting filler along with a dielectric filler so that it can enhance the energy well. So that's all. So research cannot be, I cannot say that, oh, I am thinking something different. So you have to look at that around what is going on. Then you have to put your thought with that basic knowledge, whatever you have gathered, and look at it. Then we see that if I put a conducting filler, so I'll just go directly. I'm not coming to this because time is not there. So I'll just share our research work, what we did it. And sorry. If you look at this polymer, this is just a dielectric polymer. We pick up and we have to create it the polar molecule. So for the polar, and I have to arrange it like this. This is ceramic particle. So that was the concept. What we did, we just put a stimulator of the conducting carbon film. So what happened, and it become the great story that it shows the very high voltage and the current. So then we started preparing the material and follow the procedure, scientific procedure, how you can have a systematic study. Then we look at that, what it is happening, modeling, then what we get that it give you the very good. And this is the model that we thought in your mind that what is exactly happening. If you look at that, these are the polymer, then you have this BSTO nanoparticle, then you see nothing is happening there. These are the model that we thought that inside maybe it is like that it is happening. Nobody has seen that atomic and molecule. Nobody can show you that it can be, only they can show the behavior. It's a very interesting story of the observable and your non-observable. So with that story, what we did, and I have given the reference wherever it is published, you can look at it, that chemical engineering journal. So you can look at that, and this model, it worked out very nicely. then we did all these are the devices we produce in a lab to test it that what is happening. And you will be surprised, you don't require so much infrastructure to test it. Only 50,000-60,000 in nodes and one DSO to see that what is the voltage is generated, and so that. Sir, how much time? So that is that you have to go for all the characterization and all XID and other things. As you know that in this short period it will be very difficult to exactly go that how to characterize and all. So then after doing this and all these measurement, just I will show you. So इसको थोड़ा सा नहीं बढ़ रहा है Okay, so just I was going to show that how if you tap it, the voltage is generated. So the story starts from there, how you can convert it and how can you use it for the use. So you can look at that, and there are the videos, but I don't know, it is not running. These are the videos, means that how, means you have to again calibrate and you have to look at that if you are in pressure, giving the pressure. So these are the voltage is generated, and this voltage is not very small. It's a very high voltage. Okay? So in the order of 180, 150 voltage you can generate and along with the current. So if you look at it, then you know that you have to publish that, you have to make it properly. So these are the voltage. If you look at that, it is the 40 voltage with a particular pressure you can generate. Nothing is there, just you give the pressure, then you can generate up to the 40 volt. So here you can look at that, means with the small pressure you can have the different kinds of the voltage. But the question is that, sir, what is the beauty on it? So what you are saying, that means what? The title I have given, that you have a mechanical pressure, you don't need any battery, anything. Nothing you require, you give the pressure and it can happen. And you will be surprised to know this kind of the devices are already used in the robot. But what is the difficulty the people are getting? They are using the hard piezoelectric material to get the voltage, but they are the cell powered. Hard, and it is available in the market in the, if you can buy from the Amazon and etc. You just type it and you can get it. But the problem is that they are the hard piezoelectric or the hard material. So that's why researchers are trying that if I can have a flexible, I can put anywhere. So I don't know if photo is there or not. And if you look at that, we just, as you know that you have to compare with the other voltages, and you can look at that the voltage, and again it depends upon that current, even if in the microampere current it gives. So very interesting. If you go to the school project also, nowadays the students are also doing some project on this, because it is available in the market, that I told that hard. But it is our, what is our research goal? That we have to bring the flexible nanocomposite materials which can be utilized in place of the hard, so that it can be extended its use. And if you go to the robotics, and it is almost in the robotics application, everywhere it is used, in the eye and everywhere it is used. So these are the reference that I showed you. Then finally what to do, you have to generate the power. So you have to do the electrical circuit, collect that power, so that you can use for the mobile charging and other things in the application. So research extend there, and we develop lots of different kits, remote to remote it, so that these activities we are doing. So if anybody interested, and they can look at it, that what we can do together. But the story does not lie there, and if I told in the beginning, we had used the PVDF and put the BSTO, there is another dielectric material, then as a chemistry, if you look at that, we put again multiple carbon nanotube or the stimulator as a conducting filler. But then we thought that can we replace it with a single material, because if you put the three materials when you are mixing, and something will be somewhere and someone will be somewhere. But if I put the only one and nanocomposite, I can get it. So that's what we look at that which material can be best. And the first time we just pick up alloy. People are not trying, and because they think that magnetic alloys, they will be agglomerated. So with lots of difficulty, we could disperse it properly, the magnetic alloy, but only one material, not the multiple material, so that it will be easy to process. Then we took the manganese aluminum, which is knocking the door, that to be used in the technology, the next magnetic material. So we just pick up, and we were working long back. So I thought that we can take that material because it is conducting as well as very anisotropic, highly anisotropic. So that we try to do it, and it is also the similar way we did it. So I'm not going to there, and these are the results, that what voltage is coming and current is coming, that we did it. So, and this is that by leg, putting in the chest. So everywhere we tested, voltage is generated. Okay, so then we calibrate that how you can use it. Even if you can make a pressure sensor, just you put it here, and device is not, you don't require that to make it in a very highly sophisticated lab, and we have generated and we have tested. I don't know if this figure is there, and you can look at that. These are the, this figure you can look, and he is sitting there, he just put it and tested that voltage is coming or not from your breathing. And interestingly, the voltage is sensing because of only small pressure from your heart. So these are the possibilities that as a researcher you can do, and where you can do it. And this is the paper where we have shown. So I'll be coming to the end. I think I've passed the message, that exactly what I want to say. So as you know that in short period I can tell exactly what is that. But if anybody is interested, and you can drop the mail and I can give, or you can refer our paper and it is written very nicely, you can understand. So these are the take-home messages for this talk, that a low-cost, lead-free, flexible and multifunctional piezoelectric nanogenerator based on relaxer ferroelectric perovskite materials for energy harvesting applications and transfer for robotic applications, and tertiary PVDF based polymer that I told that it can be used in the robotics, and also the single alloys which can produce the lots of things. So I would like to say that when you have the independent thought, and you will be happy that sometimes the output comes and 4 years back, and we started thinking something that to put it. So just 2 days before, and we got a message that it is in the leading publisher in the IOP. So we struggled to publish a paper in the IOP, but we got a certificate that, and it is the most cited paper among the 1% to be published in entire IOP. So such kind of things you get when independently you thought. This is the message. So my request is that it is not that I can follow something, but independently thought something and what I can contribute. If I get the chance, and sometimes also I will share, or he can share that exactly how it is very simple, but it is different from the others. Nothing is there, no violation of the scientific grammar, with the scientific grammar, but it is different from the others. And that is nothing but in the composite also, but magnetic composite. And thank you very much for giving the time. But if you need any more information, and definitely I will be happy to pass. Thank you very much.